Hi everyone and welcome to the channel. Today we will be covering real-life applications of differentiation. This video assumes you have a basic understanding of differentiating basic expressions. Already in your A-level maths course you should have covered this. By this stage you have probably only learned differentiation from a purely mathematical standpoint. Now we get to apply it to some real-life problems. So with no further ado, let's tackle the first problem. So, the question is, the motion of a body travelling in a straight line is given by the equation s equals 60t minus 15t squared, where s equals the displacement from the original position after time t seconds. Find the time taken to reach the maximum displacement s and therefore the magnitude of s. So, let's write out the equation. T squared. Now let's take the derivative of s with respect to t. So 60t becomes 60 and minus 15t squared becomes minus 30t. Like I said, I am assuming that you have basic understanding of differentiation for basic expressions. Now we want to find t. So we equate the equation to 0 because to find maximum and minimum values of a derivative it always equals 0. So 0 equals 60 minus 30t. Add 30t to both sides. Now divide through by 30. The 30's cancel. 60 divided by 30 is 2. So that means that t equals 2 seconds. Okay, so now we have t. We can substitute this back into the original equation. So that would be s equals 60 times 2 minus 15 times 2 squared, and this gives us a value of s equals 60 meters. So that's our final answer. You may be interested in online checking out the Desmos graphing calculator. So let me just show you. So with our equation was s equals 60t minus 15t squared. Oh, whoops. And here you have the graph for that. So if you look, as I scroll out, that indeed the maximum displacement is 60 and does indeed occur at 2 seconds. So I hope that's useful to you. So to our second problem, very similar to the first, but just to give you a little bit more practice with these type of problems, let's go through this one. So the question is, the surface area of a container A is given by the equation A equals 50x minus 4x squared, where x centimeters is the length of the container. Find the value of x, which makes the surface area maximum, and therefore find the maximum area. Okay, like as before, let's just write out the equation. Okay, so let's find the derivative of a with respect to x. So dA over d. Hold on. Don't know why I did that. Okay. Equals 50, because the derivative of 50x is just 50. And derivative of 4x squared is just 8x. Now again, remember, we have to make the derivative equal to 0 to find the maximum. So 0 equals 50 minus 8x. Add 8x to both sides. So we're left with 8x equals 50. Divide by 8. And we're left with x equals 25 over 4, or 6.25. So all we do now is sub this back into the original equation for A. Oh, that's centimetres, by the way. So A equals 50 times 6.25 minus 4 times 6.25 squared. This should give a value of 1, 6, sorry, not 6, 1, 5, 6.25 centimeters squared. Now moving on to the third problem. This problem is a lot trickier and more long-winded than the first two, but hopefully you can bear with me as I talk you through it. So the question is, a closed box is made with dimensions 3x centimeters plus x centimeters plus y centimeters that uses a total amount of wood of 400 centimeters squared. Show that the box has a volume of v equals 675x minus 9x cubed over 4, and then use differentiation to find the maximum volume of the box. Now I'm assuming you guys are very familiar with the formula for a volume of a box. It is literally just the length times the width times the height. If you take your attention to the diagram in the bottom left corner here, we have the box or cuboid with the dimensions given in the question. So the length is 3x, the width is x, the height is y. So what is the volume of this box? It is simply v equals 3x times x times y, which simplifies to 6x squared times y. Now the question asks us for the volume in terms of x's, but here we have it in terms of x's and y. So we have to find a way of eliminating the y value. And a way to do this is to consider the surface area of the whole box, and construct a second equation where we can extract y from it. So what is the formula for the surface area? Well, it's literally just the sum of all 6 sides. So this would be surface area equals 2 times 3x times x plus 2 times 3x times y plus 2 times x times y, which simplifies to 6x squared plus 6x y plus 2x y, and we can combine the like terms here. So it is 6x squared plus 8x y. Okay. Now the question tells us that the amount of wood used is 450 centimeters squared. So what we want to do is just equate this equation to 450. Now we need to make y the subject of this equation here. So just performing simple algebra, we would have 450 minus 6x divided by 8x, and that equals y. Okay, so now we substitute y into the formula for the volume. Remember, the volume is 6x squared times y. Oh, forgive me, it's 3x. It's 3x, not 6. Okay, so V equals 3x squared over 450 minus 6x squared over 8x. So there's our formula in terms of x's. We can simplify this by cancelling that x with the x squared and multiplying through by 3x. So V equals 1350x minus 18x cubed over 8x. Now we can simplify this further by dividing through by 2, which would leave us with V equals 675x minus 9x cubed over 4. Oh yeah, sorry, 4. No, there's no x here. Yeah, it's just 4. Sorry about that. Right, so yeah, we have our 675x minus 9x cubed over 4, which is what the question asked for. So brilliant, we've got that part done. So now we want to find the maximum volume of the box using differentiation. So we just take the derivative of d with respect to x. So dv over dx equals 675 minus 27x squared. Again, I'm assuming you have an understanding of basic differentiation over 4. Now again, as in the previous two questions, we want to equate the derivative to 0 to find the maximum volume. So 0 equals 675 minus 27x squared all over 4. So now it's just simple algebra. So we multiply both sides by 4 to remove the 4. 0 times 4 is 0. So 0 equals 675 minus 27x squared. Adding 27x squared to both sides gives us 27x squared equals 675. Divide both sides by 27. We are left with x squared equals 25, because 675 divided by 27 is 25. Then square root x equals 5 centimeters. Cool, so then we can find the maximum volume just by plugging in the 5 centimeters into the formula for the volume. So V equals 675 times 5 minus 9 times, oh, that's 5 there, 5 cubed. I'm new to using this tablet, so I'm not the neatest or the best at it. So 675 times 5 minus 9 times 5 cubed, and this comes out as 562.5 centimeters cubed. And that's our answer.